In Unix, when we need to deal with files other than standard in, standard out, and standard error, we need to be able to open and close those other files. And we need to be able to create new files for temporary purposes or to write output or whatever we may need to do in the function of our program. Open, the open call, is used to open existing files that are already on the file system. Create, notice the E is missing off of it, it's just CREAT. That is correct, I didn't typo that. Create is used to create new files or to append to an existing file. These work just like fopen that we saw earlier, except that these calls are lower in the operating system and they return a file descriptor rather than a file pointer like we're used to dealing with. There are three possible flags that can be used on the open call, and that's to open it for read-only, open it for write-only, or open it with read-write access. And those items are defined in the fcntl.h because you will have to include filecontrol.h if you're going to be dealing with this level of the operating system and file system. Permissions are exactly the same kinds of permissions you're used to seeing in Unix to set read, write, and execute for owner, group, and all others on a file. So for example, Octal works well for this. So if we have 0666 would give you read, write for owner, group, and others. There we see an example open call where it returns a file descriptor back to us. It takes in a character pointer file name, and that's just a pointer to an array or a string that contains the file name on the operating system that we need to open. Remember, an open call that must already exist. Then we have an integer that is the flags, and that flag value right there will be one of those three. O read only, O write only, or O read write that we have up there for flags. On an open call, the perms will always be 0. Int perms will be 0 for what we're doing here. In the create call, when we're going to create a new file, we give it the file name as a character pointer and the permissions that we want to create this file with. And after create is successful, it will give us a new file descriptor. Now, there aren't all that many file descriptors available to a program while it's running, maybe about 20 or so, and it's going to depend on your operating system and how your C is implemented and other things in your kernel as how many files you're allowed to have open at one time. So you will most likely have to reuse file descriptors if you have to deal with a lot of different files. To do that, you close a file descriptor. So you close and you pass it that integer that you receive from the open or create, and that will flush the buffers and take care of the other maintenance housekeeping that needs to happen to properly close a file. If you exit a program or hit the final brace or return out of main and close, and the program ends and closes, it will close your files for you. It's not very good practice to leave files open and not close them in your code, but the compiler will take care of it for you in the program. An unlink is basically a remove or a delete. If you do an unlink with a file that you have targeted to delete, it will take care of it. Unlink is the delete or remove file that you can use from within your code. You might want to do that if you've created a temporary file, let's say, to store something in the middle of your run. So that's open, create, close, and unlink, which are the low-level file handling calls.